Okay, this is just going to be an introduction to electrochemistry. Okay, electrochemistry is the study of when we make conversions between electrical and chemical energy. So in some cases, we're going to be using electricity to cause a non-spontaneous reaction to occur. In other cases, we're going to be looking at a spontaneous reaction producing electrical energy that we can use. Okay, so the first example is a voltaic cell. Okay, that's the first kind of cell we're going to look at. It's sometimes called a galvanic cell. They're kind of interchangeable. Galvanic's a little more old school. Okay, this is when you take a spontaneous reaction and you allow it to occur, and it generates electricity for you, and then you can use that electricity to, say, light a light bulb. Okay, batteries are basically voltaic cells. Here's a picture of a voltaic cell, which is a little confusing, but basically there's going to be a couple of electrodes, okay, and a reaction's going to occur, and it's going to cause electrons to move through a circuit and use it to light something like a light bulb. That little symbol can be anything, like a light bulb or a toaster or an oven or whatever. Okay, so we'll go through all the little details of this, but this is kind of what a voltaic cell looks like. A little complicated looking, don't get freaked out yet. An electrolytic cell does the exact opposite. Okay, this is when we use electricity to cause a non-spontaneous reaction to occur. So we have a reaction that won't occur on its own, so we pump electricity through it. We use a battery, and we make electrons go through and cause the reaction to occur. Okay, so this is called an electrolytic cell, and it's the exact opposite of a voltaic cell, and we'll look at that one individually also. So some of this unit is review, okay, because all of the reactions in this unit are going to be redox reactions. Remember redox reactions? Oxidation, reduction, fun and games. So we always have two half reactions. The oxidation is when we lose electrons. Okay, so there's a half reaction that produces electrons. The reduction is when we gain electrons. So those electrons that got produced get used up. Okay, and these always come as a pair. You can't have an oxidation without a reduction, and you can't have a reduction without an oxidation. These half reactions occur at electrodes. Okay, we have positive electrodes and negative electrodes. The positive electrode is called the cathode, and the cathode is where the reduction takes place. So for instance, I might have some copper ion getting reduced, so gaining electrons to make some copper metal. Okay, so I might have at that cathode, that electrode, I might have a reduction taking place. At the anode is where the oxidation takes place, and the anode is negative. Okay, so this is where we have, say, for instance, zinc, solid, producing zinc ion, and 2 electrons. Okay, and then the overall reaction of these two things, we would just combine them, right? And we would say copper 2 plus zinc solid produces copper solid plus zinc ion. So what happened to the electrons? Well, they canceled out. Okay, so you probably remember doing this in the fall, and this reaction right here is spontaneous. Okay, and later we're going to learn how to measure something called voltage that will predict for us whether a reaction is spontaneous or not. So we know that, I'm telling you, this one is spontaneous, so it produces electricity, and you can use that electricity to, run a light bulb or something. So here's just kind of an overview of the two things that we talked about, galvanic cells and electrolytic cells. Okay, remember the galvanic cell is when you use a spontaneous reaction to make electrical energy. Electrolytic is when you use electricity to cause a non-spontaneous reaction to occur. Here, the reaction produces the electrons, and they move through the circuit and light the light bulb. Here, you have to plug it into the wall, and then that forces the electrons to cause that reaction to occur. So in the next sets of videos, we'll look at each of these individually.